I'm Shiloh Brooks, and I'm the faculty director of the engineering leadership program here in the College of Engineering Applied Science at the University of Colorado. And if you don't know about our program and you don't know how you found our way to this talk and you don't really know what's going on, we're an undergraduate program at CU. And we offer courses on the theory and practice of leadership. And we do this by putting philosophy and history and literature into conversation with science and technology. Because, we think that technical education alone prepares you for a lot, but it doesn't fully prepare young engineers to confront social, moral, and political challenges that are arising from technology's influence on all aspects, especially now, of modern life. And it's worth mentioning to students out there, engineering students in particular, that our courses count for the humanities and social sciences credits that you all need to graduate. And we even offer a certificate if you want to take multiple courses with us and engage deeply in the curriculum. So we welcome any and all engineers to enroll in our courses, and our course prefix is ENLP. I have a great colleague, Angela Timandino, and she also teaches those courses. So check us out. But the lecture today, this is a new lecture series. It's the first, in fact, in the Engineering Leadership Program's 21-22 series called The New STEM Enlightenment: Political Promises and Perils of Science and Technology. And the series examines, or is meant to examine, how America's promotion of science and technology and scientific education affect American democracy. I need not say to people here, it's quite obvious how that science and technology affect American democracy every day, affect our lives every day, certainly perhaps more now than ever before. So today's our first lecture, and I want to mention we're going to have a second one this spring term, and this will take place on Monday, March 22nd, a Monday at noon, and it'll be delivered by Erin Dolgoy from Rhodes College. So, and her title is Between Certainty and Disbelief: How Different Understandings of Science Influence Expectations. So watch for registration for Professor Dolgoy. That'll be a good one too. And I want to thank the folks who helped me put this together. First, the Jack Miller Center for Teaching America's Founding Principles in History. They funded the series, and I'm really grateful to them. And I also want to thank the Benson Center for the Study of Western Civilization, because they helped me sort out the back end on Zoom and the registration and all that, which I do not know how to do, even though I teach at a College of Engineering. So I appreciate that. Let me just give you some quick instructions about how we're going to do this. So this is a Zoom meeting instead of a webinar. And we're doing this because the program, the Engineering Leadership Program, really consists of discussion courses. We thrive on face-to-face interaction. We want to provide that for you. And we want Professor Trout to be able to interact with students and guests who want to ask him questions. We want to see their faces and have a conversation. So you can be seen if you enable your video. So if you're at home having lunch in your PJs, maybe don't do that right now. But when you ask a question, you can ask it via audio, unmute yourself. You could also unmute your video and show us yourself, but we'd love to talk to you. You'll be muted throughout the presentation. But when we take questions, what you'll want to do is use the hand raise function at the bottom of your screen. I'll then see in the participation list who's got their hands raised. We'd like to privilege students first, at least for the first few minutes. And we'll call on as many people as we have time for. And then you can unmute yourself and enable your video to ask your question. So with that said, let me introduce our speaker. And it's a real honor for us to have him here today. Bernhardt Trout is the Raymond F. Baddour Professor of Chemical Engineering at MIT. And he's also the director of the MIT Society Engineering and Ethics Program, which he helped found. And this is MIT's version of CU's HERPS program, an engineering leadership program. Professor Trout was a pioneer in establishing such programs. The purpose of that program, by the way, is much like ours, to broaden and deepen students' understanding of the social and ethical implications of engineering. But in addition to doing that, he also happens to be an extraordinary scientist and researcher. His scientific research focuses on applications of machine learning, in addition to quantum mechanics, statistical mechanics, and experiments to develop pharmaceutical products and processes. And it was in 2007 that he started the Novartis-MIT Center for Continuous Manufacturing. And this is an $85 million initiative to transform pharmaceutical manufacturing. He leads public outreach initiatives to promote pharmaceutical and vaccine manufacturing. He's also, interestingly, this is my favorite part of his CV, he's the co-editor of a volume called Mastery of Nature, which is a volume on political philosophy and science. And he's published over 200 technical papers with 19 patents issued or pending. And I'll say one more thing about him. I first saw Bernhardt Trout in a political philosophy seminar on Plato. I was a graduate student at Boston College. He came over from MIT, and I thought, what is this MIT engineer doing in my political philosophy seminar? Little did I know that he would be the model of the kind of engineer that the engineering leadership program is trying to create. A curious person who is engaging the full range of their humanity in their scientific work, but who reads philosophy and is interested in the broad history and philosophy of science and science's implications on society more broadly. So with that said, everybody virtually clap for Bernhardt Trout. And Bernhardt, I give it over to you.
Well, thank you, Professor Brooks. I hope I can live up to the introduction that you gave to me. But I want to especially thank you for inviting me to speak here. I assume that if you can't hear me well, Brian, the person in charge of audio, or if you can't see me well in terms of video too, will let me know. But thanks again, both to Professor Brooks and the University of Colorado Engineering Leadership Program for the kind invitation to speak here today as part of your series on science and American democracy. I'd also like to thank Professor Minkoff of Roosevelt University, who's in the audience, who gave me some very helpful feedback on an earlier draft of this talk. And actually, he was one of the co-founders of this society engineering and ethics program at MIT when he was on sabbatical over a decade ago. So I'm going to start by sharing my screen, see if this works. And hopefully you can see that, because I was asked, this will move. Okay, we'll try this again a different way. Okay, now we're moving. Technology can work sometimes. So I was asked to address questions such as the following. How does our social and pedagogical veneration of science and technology and the heightened emphasis we place on STEM learning alter the inner life of our nation and its people? Can a citizenry educated under the auspices of modern science and technology maintain the institutions and behaviors necessary for the survival of liberal democracy? To what degree does scientific pedagogy foster or fail to foster the democratic, mutually respectful, egalitarian, civil, and tolerant behaviors required for liberal politics? Are our prospects for reclaiming a more nuanced civil discourse, for solving the problems inherent in political polarization, and for producing future leaders of prudence and character, enriched or diminished by the intellectual habits of mind cultivated by STEM disciplines? And finally, what light can great minds in the Western and American political and philosophic traditions shed on our predicament? So I would like to address these questions via the question of how science education, or more directly, the scientific psychology developed by science education, affects citizenship, particularly in America. So I'd like to start out by taking a poll. It's necessarily got to be a virtual poll, given that you're not here in person, I'm not there with you, and I can't see you. So just in your head, I'd like to answer the question with this very democratic poll. How many of you think atoms are real? And how many do not? Think about it in your mind. And I obviously don't know the statistics here. We could do a poll, I guess, and get those statistics. But I would suppose that pretty much everyone here thinks that atoms are real. And yet you might want to ask yourself, to the extent that you think that's the case, or to the extent that you don't, can you justify this? In addressing the question of the relationship between the scientific psychology and citizenship, I will start off over the next 15 minutes or so by making the case that atoms are not real. I think I'll be able to demonstrate that in this pretty short amount of time, as I mentioned. Yet we are taught pretty much our whole life that atoms are real. And I'm claiming that this teaching is wrong, and that it will only take me a few minutes to demonstrate to you that this teaching is wrong. In going about this, I'm going to start out by discussing thermodynamics and then get to atoms through their description according to quantum mechanics. Furthermore, I'm going to discuss that despite the unreality of atoms, the belief that they are real has certain effects on citizenship. And I'll spend over half of my talk on that aspect. And I also want to emphasize that I will demonstrate to you, I think, that atoms are not real. And that's even despite the fact that pictures of atoms, hopefully you can see that here, let me know if you can't, that pictures of atoms seem to demonstrate that we can see them via techniques such as scanning tunneling microscopy here. So let me start out with a very high level historic overview about how the current scientific worldview came about. Very high level. Again, hopefully you can see this. Here we see the beginnings of modern science in Bacon and Descartes, in particular Bacon's Relief of Man's Estate, which Descartes continued with his making us like masters and possessors of nature, and in particular by mathematizing nature. I will show you shortly the way this has led to the development of the scientific psychology. But first, let's continue the historical overview. Descartes' mathematizing approach for treating nature was adopted by Newton in the 18th century. And ever after, the study of motion became the application of Newton's approach. This opened up a problem for science, however. Since Newton's equations of motion were reversible, whereas basic scientific experiments showed irreversibility, there must be something problematic with Newton's approach. For example, I think we all have seen this, or we can imagine, a drop of ink put into a glass of water cannot be simply removed again back into a drop of ink. But because Newton's equations of motion are reversible within the Newtonian framework, it implies that they can be reversed, that this drop can be extracted back in a straightforward way from a glass of water. So something beyond Newton's approach needed to be developed. With much effort, that was seemingly done in the 19th century with the advent of thermodynamics and statistical mechanics. However, 19th century science still left open the question of what constitutes the microscopic, the underlying elements which leads to the irreversible macroscopic quantities that constitute thermodynamics. The unveiling of the microscopic was thought to be accomplished by the advent of relativistic quantum mechanics and reinforced by the subsequent identification of fundamental particles throughout the 20th century. So this scheme looks something like this. So in this scheme, fundamental particles interact to form atoms and molecules, the properties of which can be determined and quantified via quantum mechanics. Those properties are then averaged using statistical mechanics up here in the top of this arrow to lead to macroscopic properties. So this is a schematic, I would say, high-level schematic of the scientific view of nature. And so from now on in my talk, unless I state otherwise, I'll use the word science to mean modern science, as I've just described it, but together with modern technology. And so I'd like to start out in the 19th century. One thing that differs from 18th and 20th century science is that the driving force for the scientifically theoretical developments of the 19th century, thermodynamics, for example, was technological. So I'm going to show you an example here. This is an example of a Watt engine. Okay, so this is an example of a Watt engine. And as engines started to be developed, in particular to drain mines, but also to replace windmills for power, the obvious question came to the fore. And so let me pose this obvious question using the words of Sadi Carnot, who in 1824, at age 27, not only posed the question, but answered it. The question is, quote, "One often raises the question of knowing if the motive power of heat is unbounded, or does it have certain bounds? If the possible improvements of steam engines have an assignable limit, a limit which the nature of things inhibits being passed by any means whatever, or if, on the contrary, these improvements can be extended indefinitely." End of the quote. In order to answer that question, 19th century science went about to analyze the steam engine. And this example here of Watt's engine can be analyzed in terms of what came to be known as the Carnot cycle, which I show here. Maybe many of the students in engineering have already learned about this Carnot cycle. For this ideal system, it turns out that yes, there is indeed a maximum amount of work that can be done. Okay, this is expressed by this term eta. And it's related to these two heats, Q1 and Q2, and also to these two temperatures, which I've labeled here cold for the cold reservoir and hot for the hot reservoir. Okay. You can check out the details if you haven't come across this yet. But the point here is that there is a limit on the efficiency, and that limit can be expressed using this representation of an engine via the Carnot cycle. Now, this concept of the Carnot cycle inspired a concept which maybe many of you heard of, which was introduced by Clausius. That's the concept of entropy, S here. And for any real system, the entropy change is actually greater than 0. It's only equal to 0 in this fictitious ideal system. So since I've introduced this concept of entropy, now I'll introduce this concept of energy, which you've certainly all heard of, symbolized here by U. S is entropy, and of course, temperature, pressure, and volume are expressed by their corresponding symbols. The energy here is represented in terms of the entropy and also these other quantities. The D's are differentials, so we can integrate this equation to get, say, changes in internal energy and changes in entropy for a given process. Let's say that we want to know the change in entropy in a glass of water when we heat it up. We can calculate it as such using this term Cp, which is the heat capacity, which we can determine separately relative to some reference. Okay, so why am I telling you all of this? The first reason is to show you that according to thermodynamics, we cannot know the most important properties like energy and entropy outside of an abstraction. We cannot measure them directly. We can measure them, for example, through this heat capacity and then performing a mathematical operation on that. But we cannot measure them directly. Even by any scientific standard, they are abstract quantities. We can only compute them by measuring properties that contain less information than they do. They are purely abstract. And yet they are, by scientific standards, the essential properties of a system. So the next point about this is in order to answer the question about the limit of power an engine can produce, we have utterly abstracted that engine from anything which has any real resemblance to it, and we have homogenized it. Okay, so this is a picture of two engines. I've put the Watt engine right next to a Maserati engine, which is of course manufactured by Ferrari. According to the scientific approach, these two are essentially the same. Both of them boil down to this or some variation of it, this Carnot cycle, abstraction. So in order to master nature, we needed to turn nature into something she is not. It is something several levels removed from what she is. Of course, this works for mastery, but only by channeling nature into an abstraction. This is the approach exactly taught in STEM. And I note that concepts such as inertia, force, and these sort of things, which are more from 18th century science or earlier levels in your scientific education, suffer from a similar problem. I leave that to work out yourselves. But I promised to discuss atoms. So let's move to the 20th century. One of the greatest accomplishments is the development of quantum mechanics, which we can explore via the famous Schrödinger equation, which I have here. From this equation, the energies of any chemical system can in principle be determined, and via statistical mechanics, which I talked about earlier in that overview slide, can be used to compute those abstract thermodynamic functions that we've been discussing. The way it starts is by solving the equation for the wave function, okay? This is this capital psi term here. We solve this equation, and I note that this wave function is complex, meaning that it's a function of the square root of -1, or I. It's a complex function. And it is in an infinite dimensional complex space. So according to quantum mechanics, all information on a given system is incorporated into this wave function. And in order to get information out of the wave function, one performs an operation with a mathematical operator which corresponds to the property that one wants to determine. For example, if you want to compute the electron density of a hydrogen atom, you put the corresponding parameters into the Schrödinger equation. And then you can picture it as something probably most of you have seen, something like this, the electron cloud of a hydrogen atom according to quantum mechanics. And you can continue that for molecules. Here's another example of a water molecule, the electron density, now the charge, colored red for negative, blue for positive. And maybe some of you have seen something like this before. Here's the rub. The wave function contains all of the information on a system, but itself, it is not observable. Okay. So now, going from 19th century to the 20th century, we're even a step further removed. Instead of entropy, an abstraction which can at least be determined from surrogates like heat capacity, the wave function cannot be determined at all outside of mathematics. Okay, so here we are. This is the genesis of this high-level picture of nature as told by science. Of course, this approach is extremely useful. It allows us to make microchips and airplanes, and of course, pharmaceuticals, and certainly of pressing current importance, vaccines, but at a price. It transforms how we conceive of nature away from anything that our regular experience tells us about her to a mathematical abstraction, a useful one, but an abstraction nonetheless. Okay, I'd like to emphasize now one more aspect of this abstraction. That is, it is utterly willful. It is a choice, an imposition that we have made on nature. And by the way, we were persuaded to make that choice by by Descartes and his followers. The result of this approach or method is that science does not actually reveal nature. It imposes upon nature. In particular, it imposes a mathematical abstraction upon nature. As we have seen, this abstraction can be so far away from nature, in the case of the wave function, for example, that it borders on the insane. We are telling ourselves that a function in an infinite dimensional complex space that cannot be measured even by scientific standards is the true description of nature? Well, if you don't believe that, I think any reasonable person would think that sounds a little problematic at best. If you don't believe that, then atoms are not real. Even if you do, they're not tangible things, even conceptually. They are at best projections of wave functions which exist in an infinite dimensional complex space that we have willfully imposed. This aspect of science, by the way, was not lost on the physicists during the dawn of quantum mechanics. Some of you might know of Sir Arthur Eddington's famous two tables in his 1927 Gifford lectures. The one table is what is in front of us, that we can see and are familiar with. But the second table is the scientific one, the real one, composed of nuclei and electrons, but mainly of empty space. It is this approach to the world that I call the scientific psychology. To see more about how this willful abstraction works in replacing the real world or nature with a constructed world, I highly recommend that you read Descartes' The World and that you work examples in his rules, particular rule 12 and paragraph 6. And you can also read about this in the last chapter of Leon Kass's Life, Liberty, and the Defense of Dignity. Okay, so having unveiled the scientific psychology, let's turn to its effects on citizenship. The first 3 points that I want to make below are general, and the fourth is specific to citizenship in a regime like the American regime. The first point is that the mind developed by the scientific psychology presumes that the scientific method is the best, if not the only method to develop knowledge. Any other method pales in rigor, so much so that knowledge developed outside of science could hardly even be called knowledge. The consequence is that the human things get distorted as much as nature does, as I have explained above, but with more immediate consequences. Any human choice gets projected into a scientific problem. How could it not? If a person were educated so that person knows only how to apply scientific method, why would the person do anything else? As an illustrative example in this application to politics, I'd like to discuss utilitarianism introduced by Jeremy Bentham, for example, in an introduction to the principles of morals and legislation. In that approach, laws should be made based on maximizing pleasure and minimizing pain for each person. Now, the criterion for pain or pleasure of each person is determined by each individual, as are their degrees. So one person might consider exercise a pleasure, another a pain, and those differences would be taken into account. So here's how it works. Works as follows. Pleasure, which is P here, is posed as a large, actually a very large equation, which is a function of a law or a policy X. Pix, or Pijx here, is the pleasure or pain, positive or negative, where I is the index for the given pleasure, and J is the index over all individuals in a society. I is clearly a very large number, as is J. Maybe I is something like 350 million for this country. J is a very large number too, if you add up all the different possible pains or pleasures. Now, if a policy X increases P, it is good. If it decreases P, it is bad. At any rate, one can already see some problems with this. One is the knowledge problem. How do you obtain Pij? Right here. That is not necessarily a major limitation with any given narrow application. But it is indeed an impossibility in terms of society as a whole. The larger problem is that everything is condensed into pleasure and pain and then mathematized, much like the way in which entropy is abstracted from a physical situation, and the wave function is even more abstracted from a physical situation. But by abstracting and homogenizing those things that are most important to human beings, for example, freedom, hope, and love, doing that necessarily transforms them into concepts that are so far removed from what they actually are as to be non-representative. The whole idea of founding principles or founding laws goes away. Nothing can be intrinsically important as everything is malleable and transferable, being just a mathematical term in an equation. As such, there can be no real basis for citizenship, since there is no country or regime that could be the object of citizenship. There is no foundation in life, liberty, and the pursuit of happiness, since these are just one out of a practically infinite number of ingredients in a puree of competing goods for which people are grouped together in various geographical locations for who knows what reason. The utilitarian approach, the approach of the scientific psychology, might seem to be so far from providing a suitable description of human things that one might wonder why it would even raise that as an issue. But isn't this what the social sciences, economics, and political science, for example, do today? And in doing so, freedom is lost as the policies advocated by social science line us up in the best scientific way, like those xenon atoms in the nickel surface that I showed you earlier. So let me move to my next point about the scientific psychology and its effect on citizenship. Because the scientific psychology disdains any knowledge that is not science, it is completely open to absorb whatever trends happen to emerge. It is helpless to reply to arguments which require subtlety beyond mathematical subtlety, or to see a situation in its fullness. Much like the engine becomes a Carnot cycle, the human things becomes a formula. For example, the question of whether a new law is good or not involves the specifics of the situation of a polity, both domestically and internationally. They involve different groups and what animates them, and they involve respect for the existing order. For innovation in laws leads to loss of respect for laws. However, within the scientific psychology, there is no reverence for the old or even the tried and true. Everything is subject to revision. Everything is changeable. Everything can be made better, so it should be. Some of you might remember Aristotle's discussion of Hippodamus in Politics 2:8. Hippodamus was most ambitious and wanted to institute a city based on mathematical principles. Moreover, he wanted to create incentives for innovation. Aristotle critiques him in various ways, and at the end summarizes the problem with innovation in politics. I'll quote here. The argument from the example of the arts is false. Change in an art is not like change in law, for law has no strength with respect to obedience apart from habit. And this is not created except over a period of time. Hence, the easy alteration of existing laws in favor of new and different ones weakens the power of law itself. The scientific psychology craves innovation, But citizenship is about respect for the existing order and its preservation. A similar observation related to what we have experienced in the US in recent months can be seen in Lincoln's Lyceum speech on the dangers of mob rule. Lincoln discusses how mob justice, even if its ends are right, hanging a known murderer, for example, works against the existing order by making even good citizens lose faith in that order and its ability to protect them. The consequence of this is the erosion of citizenship and the erosion of order, and at its extreme, collapse of the regime. We see a similar manifestation today in the regulation of speech. Today, for example, the trend might be not to say banana. Tomorrow, banana is okay, but not pineapple. If speech is just another term in the pleasure equation, homogenized to be like everything else, why shouldn't it be controlled? There's no real way to defend speech as such within the realm of scientific psychology. If 100 people do not like what one person has to say, why should they be subjected to it? More generally, there is no way to defend freedom if it is a mere term in a cost-benefit analysis. Freedom needs to be hollowed over time, and the habit developed to think of it as needed also needs to be developed as something intrinsic to human nature and even ennobling. Okay, let me move to a third consequence of the scientific psychology and its homogenizing effect in the world. As it homogenizes nature, it should be evident that what is lost is the particular. For mathematics deals with the general, the universal. There is no essential difference between a Watt engine and a Maserati engine, or for that matter, between a cow or a sheep and a Watt engine, or a sheep and a human being. There is no essential difference between anything. The essence of everything is in a mathematical representation and the parameters which go into that representation. However, one can only have affection for or love particulars. One cannot love a mathematical equation, 3x cubed plus y equals x, for example. Love can be for people, pets, of course, or countries. And love of one's country is part of citizenship. One of the hallmarks of science is that it is universal. The efficiency, as I've discussed, of an engine or the plot from a quantum scattering experiment is not different in the US or China, all other things being equal. Science in its universality, made possible by its willful abstraction of nature, erodes citizenship. This, of course, does not mean that a particular scientist cannot be a good citizen, but the fact that he or she is one is independent of science or even despite science. With that in mind, I move to the fourth point that I'd like to make on the effects of the scientific psychology on citizenship. The scientific psychology leads to rule by experts and therefore draws away the basis of liberal democracy, rule by the people. These experts, informed in their particular arts by science, no doubt know something. However, remember Socrates' analysis in the Apology. He says, "I went to the artisans, for I understood that I had knowledge of nothing, so to speak. But I knew that I would discover that they at least had knowledge of many noble things. And I was not wrong about this. They did have knowledge of things which I did not have knowledge of. And in this way, they were wiser than I. But the good craftsmen also seemed to me to go wrong in the same way as the poets. Because one performed his art nobly, each one deemed himself wisest also in the other things, the greatest things. And this discordant note of theirs seemed to hide that wisdom." In other words, one who specializes in certain enzymes in mitochondria or the wave function of a particular atom probably does not do much harm to democracy in themselves. However, when people start believing that scientists have some kind of special knowledge that entitles them to rule, democracy erodes. This is once again particularly problematic in the social sciences. economics, political science, in which mathematical abstractions of human things, such that they are turned into what they are not, becomes models to make decisions about human things. Okay, so having said those 4 points and discussing the incompatibility of the scientific psychology and the education which forms it with citizenship, I want to add a positive note. Despite the corroding effect on it, on citizenship, at least it is compatible with the idea that nature can teach us something. It is compatible with the notion that some things are better than others, since there is a way to compare 2 or more mathematical abstractions. And while it is unable to fight against encroaching nihilism, it could at least form a bulwark against it. Can this bulwark be built in a way that is compatible with liberal democracy? I think that the answer is yes, but it would take a major shift away from the way it is currently taught. First, we must recognize explicitly that because atoms and the other products of scientific abstraction are fictitious, willful contrivances perpetrated to gain mastery over nature, and for that matter, to gain acquiescence to the scientific project, we must make clear the limitations of science to teach us about nature. This is not to say that science is not useful to generate wealth, to promote health, and to build a strong country, all things which are in consonance with democracy and the American regime. But outside of these, they provide so little understanding of nature, outside of mastery, that they can be dispensed with without loss. For citizenship, it really doesn't matter if people believe that things are made of atoms, or of water, or fire, or that everything is in everything, or whatnot. What matters is that we fortify ourselves and our students against the tendency of the scientific psychology to corrode citizenship. For that matter, the same tendency leads to the ossification of science itself. So even die-hard scientists have a stake in addressing this problem. In order to address it, we must understand the true place of experts. They are important and useful, but very limited in their application. And they should certainly not be the judges of life, liberty, and the pursuit of happiness. We must promote rule by the people, not just certain classes of people, and teach our STEM students this. That however important STEM is to individual accomplishment, wealth generation, and whatnot, it is subordinate to and made possible by the American regime. In fact, justification of the approach that I'm proposing follows from what scientists say themselves. Recall Eddington's second table, the true table as he calls it, the table of electrons and nuclei, consisting mostly of empty space. Of course, Einstein famously expressed his disbelief in quantum mechanics by his "God does not play dice." Eddington was somewhat more introspective in his Gifford lectures. He said, "Science aims at constructing a world which shall be symbolic of the world of commonplace experience." So for Eddington, what I have been calling a willful contrivance, he calls a construction of symbols. Towards the end, he says bluntly, "Scientific investigation does not lead to knowledge of the intrinsic nature of things." Said by Eddington himself. Such were the thoughts of the time of the inventors of quantum mechanics. A generation or so later, however, these concerns had faded away. And those who were supposed to be the investigators of nature took quantum mechanics as simply true. Today, one can read a host of compelling books on science by a variety of very smart scientists. However, these works themselves exemplify the ossification of science, which results from the scientific psychology. Thus, in their popular works, scientists these days tend to be playful. One talking about how a bunny rabbit is just a mathematical formula in a complex vector space, and another saying that science isn't everything, it is the only thing. Such playfulness indicates a thread of understanding of the intrinsic problem with the scientific psychology, a problem created itself by Descartes, but at the same time, it indicates an utter lack of ability for this psychology to address its own problem. This leads to an obtuseness that can only have the practical effects that I've been describing above. And promoting such obtuseness is what we mean by a STEM education, unless it goes together with a broader education to address these effects. Of course, science has made great accomplishments and should be appreciated for them. It is not fine, however, and goes against American citizenship to accept the tenets of science as the only principles of nature. Science should rightly be subsumed under the principles of the American regime. To quote Lincoln from his speech at Edwardsville, "What constitutes the bulwark of our own liberty and independence? It is not our frowning battlements, our bristling seacoasts, the guns of our war steamers, or the strength of our gallant and disciplined army. These are not our reliance against a resumption of tyranny in our fair land. All of them may be turned against our liberties without making us stronger or weaker for the struggle. Our reliance is in the love of liberty, which God has planted in our bosoms. Our defense is in the preservation of the spirit which prizes liberty as the heritage of all men, in all lands, everywhere." The same can be said about science. The scientific psychology developed by STEM education needs to be placed under a broader canopy of civic education to counter its corroding effects on citizenship. So, as addressing the scientific psychology in this way, we will not help but meet the connection between civic education and liberal education. The famous words from the Declaration of Independence that I've been quoting, perhaps the most famous words in America, life, liberty, and the pursuit of happiness, are themselves an abstraction. They are made concrete by the Constitution, but they are not justified by it. The justification comes from philosophers like Locke, who, for example, in his second treatise on government, based the foundation of civil society on a deep analysis of nature simply. It is the education based on this type of study that we should pursue, and in doing so, subsume the scientific psychology under the full light of knowledge. Thus, I'm not simply criticizing science. Science, as I've indicated, is a remarkable achievement. But it's remarkable, I would say, above and beyond the goods that it can get us. Eddington's wonder of the second table is a reflection of our wonder of the world, a wonder that can be turned back to the question of why nature lends herself to mastery. 400 years after the dawn of the project of mastery, this question has never been answered satisfactorily. Furthermore, how did science succeed in taking over the world? No less a thinker than Machiavelli, I would suppose, would be interested in answering such a question. If science is the reigning opinion about nature today, it is certainly an important part of the whole, and we need to understand it to be able to attempt to replace opinions about the whole by knowledge of the whole. For the human mind grasps for answers and is content to stand upon an answer that is complicated enough to seem plausible, even if at the end of the day, it is a cardboard construction. As Bacon writes in the Novum Organum, Part 1, Aphorism 46, the human intellect takes the conceptions which have won its approval by general acceptance, credit, or simple charm, and pulls everything else into line in agreement with them. Thus, while we need to go outside of science to understand nature as she is, we need to go beyond the scorn that follows when one has pulled open the curtain and looked at what is behind. The dramatic illusion will be gone, but something still remains of importance backstage. Perhaps indeed, the costume racks and the makeup trays, the lifts and the pulleys, and the lights and the scaffolding, not to mention the brooms and the dustpans, can in this way be of more interest than the drama itself. After all, who wouldn't want a backstage pass if you can get one? But yes, in doing so, we will have to go beyond science as I have defined it for the purposes of today, that is, beyond modern science. Now we can think of science in the full sense of the term, where science is simply, as its root is, knowledge. And it's knowledge broadly, so it cannot be subsumed under a method or even under politics. So hopefully, this afternoon, as I've unveiled modern science, I have left you with the desire to understand modern science, both for what it can do or for what it can teach theoretically. Moreover, I hope that I've inspired you to find alternatives to modern science for understanding nature. A good place to start would be to study, for example, Aristotle's physics for 3 or 4 hours a day for a year. Thank you very much.
Thank you so much, Bernhardt. Wow, what a talk. We have some time for questions. And so what I'd ask you all to do is use the hand raise function. Just click that. I'll see you go up to the top of the queue and then unmute yourself. You can turn on your video if you want to. You don't have to do that, but and we can get to some of the questions. So click that hand raise function. Let me start while people are thinking of questions by just asking you, I wonder, as you were talking, you know, it's a profound critique of science that you leveled, and clearly something you've been thinking about. You mentioned reading Aristotle's physics for several hours a day for a year. I'm curious how this critique of science has affected your own practice of science, the way you do it, the way you teach it. In other words, your self-understanding of your own activity. You harbor in yourself, you know, a certain tremendous scientific capacity, at the same time, a capacity to criticize that very activity. And so I'm curious how this has shaped your own endeavors and self-understanding.
Well, that's a very, very big question. So I think the big answer to that question is, as I described it today in my talk, it does lead to the problem of being a stranger in one's own world. That is, if the world is the world of science. I would say from a scientific perspective, let's say as a practitioner of science, perhaps, although I'm not sure, but perhaps it's allowed me to go against the grain a bit. And so develop different areas, we call them subfields of science, in which other people maybe didn't think of or weren't willing to go into. I think the big issue, though, is really personally, I think it's allowed me to understand the world better around me. But that also, of course, is not without disappointment. As I mentioned at the end, part of the enjoyment of the drama is seeing it unveil. And well, I guess the first thing one learns in acting is not to break character, but if you can see the truth behind the characters, that can break down the illusion.
Yeah. Thank you. Thank you. I might press you on that later, but at any rate, Wyatt, you have a question. Can you unmute your mic? Wyatt is a student.
I do appreciate you showing your video. That's nice. We're trying to make it more interactive, so I appreciate that.
Of course, yeah. So over your talk, you mentioned several times that one of the issues with science is that it is corroding the effects or corroding citizenship in a society. And I was wondering if you could elaborate a little more on what you mean by citizenship. Is it more referring to nationality or simply an appreciation of being under a set of laws? I guess, could you elaborate a little more on that, please?
Yeah, I've been taking it to mean, I think, nothing special, but you're certainly right to inquire. I just take it to mean, let's say, devotion to one's country, including the laws, particularly the foundational laws of one's country, and acting with those laws in mind. I'd say it's simply like that. Does that kind of help? Feel free to keep pushing if that.
Yeah, it does. And slightly to play devil's advocate here, I hope you don't take this the wrong way, but how is that different to blind devotion then? That's
good. Well, why would I take it the wrong way? You said you were the devil, not me. So, because it should, I guess that was the case I was trying to make at the end, because it shouldn't be blind, it should be thoughtful. There is something of the particular. One has adopted, let's just say, our country. Not all of you might be citizens of this country, may not even all be physically here right now. But to the extent that you were born here, you chose to stay here, you adopted the country. There is, something outside of pure negligence, you must think, that you owe to your country. There's some sense of devotion. It's not just blind that you respect your parents. I don't think you're making that argument. But I think you do raise the point, which I was trying to make only briefly at the end for lack of time, the need in civic education for liberal education, which I think itself is broader. And I mentioned Locke in particular. I don't know if you're familiar with Second Treatise on Government, in which he makes a very profound argument for the natural basis of, say, what came to be the American regime. So I think in all dimension, it is very far from blind devotion, but it doesn't have to be purely rational.
Okay, thank you.
Yeah, you're welcome.
All right, we've got a couple more here. I'm gonna go with Mary Elizabeth Halper, our good friend from the Hertog Foundation. And then we've got, I know, at least one student, maybe a couple others.
Hi, Dr. Trout. It's nice to hear you talk about this really interesting topic. I hope I'm not taking too much time away from the students, but I want to ask about this topic from sort of the other perspective, from someone who's doing politics education and philosophy of science, a personal preoccupation of mine. I wonder, from that direction, how should people who are primarily interested in politics be thinking about science? Where can the two roads meet? A lot of what you said kind of reminded me of the phenomenological tradition with Husserl and Klein, kind of need to return to the life world, recovering pre-scientific experience. Is that a possible pedagogic path? And if not, what would you suggest in its stead?
Well, actually, I guess I would recommend the opposite. I would recommend that you try to investigate and teach your students. And in a sense, this talk was written for engineers. So if I were to write this talk the other way around, I would probably make the case stronger, although I started to do it at the end, but I would make the case stronger that as someone interested in political science, maybe political philosophy and the philosophy of science, that you should try to understand science as it is, including the historical development. And in a sense, maybe reverse my talk and try to go back to the origins, try to understand what Descartes was doing, but I'll try to understand the consequences. I'll add one more thing, and your question, I was going to fit it in somehow. Your question, I think, is a good opportunity to do that. I didn't have time during my talk, but there's something fascinating which I've been studying for many years, which is a modern alternative to modern science as such, and that is Goethe's approach to science in his theory of colors. So that's perhaps another direction, which would be another talk for another day, but that's another direction you could pursue, but after you go and try to understand science as such. In a sense, I jumped in and went quickly to the abstraction and contrivances in science, but I would say you should go back and try to see to the extent to which that's not the case.
Thank you.
Phoenix Bloomfield, a student in our engineering leadership program, in one of my classes right now. Phoenix, do you want to unmute yourself and ask a question? Go ahead.
Sure. So I had a question kind of building off one of the previous ones where you're talking about blind devotion or lack thereof in a good citizen. And I was wondering, how do you view, like if law is unjust in a society, how do you view the role of a citizen when faced with that law? Like what should people do if they believe that there is an injustice, or how should they go about that?
Well, I'll say a couple things. The first thing is you go about it within the framework of laws of the regime. I mean, it depends. Obviously, there could be a instance in which society is so corrupt that it needs to be overturned. Of course, the foundation of this country is in a revolution, and certainly that's discussed extensively in Locke. But you know, work against the law. In particular, this is the other point, you should think carefully about why that law is unjust. I think that's part of citizenship that we really tend to ignore today. It seems to have collapsed into interests. So something is unjust because it's against my interest. Or maybe it's against a feeling. But I would say you need to reason that through, and I guess investigating the kind of thinkers that are taught in the engineering leadership program. And I know Professor Brooks is one of your professors this semester, so certainly the kind of things that he teaches is a way to do that. But I think it can't be done superficially. Does that start to?
Thank you.
Welcome. Great questions.
Thank you, Phoenix. And we're going to get to this soon because Lincoln's going to talk about what to do when there's an unjust law. So hang tight. At any rate, Sam Allen, I see your hand up. If you'd like to unmute yourself and ask a question, please go ahead.
Hey, I was wondering if you could try to explain what the wave equation represents, a little more how we know this or other scientific descriptions are right. And then I had a question more on your main point.
Sure. So the wave equation is, let's say, applied to explain certain patterns that emerge from certain types of experiments. In particular, experiments in which light, let's say, interacts with matter. And so what was discovered by Schrödinger in 1926 is that this wave equation as such, the Schrödinger wave equation, is able to generate certain, let's say, lines in the spectrum which are associated with atoms, in this case, the hydrogen atom. And so then over the years, that equation has been generalized to explain much more complicated systems. I showed you a water molecule, and systems, of course, much more complicated than that. And you know, I think what's amazing about this wave equation in terms of explaining these certain subset of patterns is that it's never been found, there's never been an instance found where under those certain circumstances, the certain patterns that are generated, in which it doesn't, when properly applied, describe the phenomena. But it's under those particular circumstances that I've been discussing. does that start to help with?
Yeah, and then wondering, with part of that, the scientific explanations are the best ones that we have. Could we go as far to say that things existing couldn't be otherwise? We know these formulas couldn't be different, or that what we are looking at for the phenomenon of atoms couldn't be otherwise. And then could we do a similar thing with knowing about what the goods are, like truth or beauty? We may not have a good way of knowing what they are, but couldn't we think that there's a perfect form of them? Just as we're using science to know more truth about reality, could we know more truth about political ideas?
Good, excellent. And I guess I started to touch upon those in my talk. First thing I would say is, I guess I'm making the case that your premise itself is not correct, that science doesn't actually teach us about nature. It obfuscates our understanding of nature. That's why I call it a willful contrivance. It's a willful contrivance that we impose on nature. So it really pushes nature away more than pulling it towards us or giving us an understanding of nature, except in certain areas, like why is nature, why is it so subject to such a contrivance? Having said that, I think your first part of your question is very well taken. And so think of it this way. This is why I included at the beginning this very high level overview of the history. You have these incredibly smart people from the time of Descartes who devoted their entire lives to advancing this Cartesian willful contrivance. Newton, etc., up through 19th century. I talked about Carnot, Clausius, others. Of course, we're all familiar with Einstein. Maybe some of you know Richard Feynman. And literally hundreds of extremely smart people who devoted their entire lives to this, plus probably tens of thousands, if not hundreds of thousands of others. So the particular direction in which modern science has evolved to lead to the wave equation, which you asked about, and other things, perhaps that could have gone in another direction. What if there's another 100 very smart people who devoted their lives to go in a different direction? And this is why I encourage you to study Goethe on colors, because Goethe is an example of an incredibly smart, incredibly impressive mind who did go in a different direction. And he did spend a good part of his life, a very large part of his life. And he had a completely non-Newtonian approach to experimental science. However, he didn't have any followers, so to speak. He's had some followers, but basically Newtonian science won over. So imagine the whole thing could be very different if it had gone in a different direction. You sound like you might be an engineering student, so you can think about it this way. It kind of formed a phase transition into the particular phase of science that we have now, but it isn't necessarily the only phase. As far as beauty and truth, I guess I simply make the case that abstracting these into quantities as such removes them so far from what they are that if one thinks about them that way, really thinking about something completely different. But do you have a different view of that? You think a mathematical representation of beauty is accurate?
I suppose more when we're trying to figure out policies, is we're not thinking in abstracts as much, but we want to know what is the best policy maybe in a utilitarian sense for the greatest good or in some other sense. And those things, seems like we would have a way to know what's best. And sounded like you're saying that we tend to homogenize them and we're not really getting to a way to understand them maybe as well as we do in science. So do we know when policies are best in the same ways that we know science came to a good conclusion?
So, I mean, my argument to that is no. So I didn't have time to develop this much, but I think I can make the case, and maybe you can already see it from what I discussed. Science and engineering is intrinsically utilitarian. You're always optimizing something. You're quantifying and optimizing it. You cannot escape, let's say, from this utilitarian framework. Now, a utilitarian approach has got to be part of any law or policy or any approach. I mean, I think human beings have understood this from the beginning. You only have so many resources. You have to allocate them somehow. Generals or other officers have to make decisions, essentially utilitarian decisions. But the point is that law, I mean, I've given several reasons for this, law or what's under those policies are broader than that. You might have to take these into account, but you have to take other aspects of human nature and human things into account too. Not everything is just reducible to a utilitarian approach. I'll just give you an example. I couldn't include it here, but we teach that. You can look this up. There's a famous memo from the Ford Motor Company. You can find it online. And it was a memo in which they did a utilitarian analysis for whether a certain safety feature should be included. The safety feature cost $11. But when you spread it over all cars and trucks, it's over $100 million, 1970s dollars. But if you calculate the number of deaths that it will save, the number of burnings it will save, and the number of automobiles that it will save, that number is much less than the 100 million. It's like 50 million. So of course, under this framework, you would not advocate for that part. If I show you this in the screen as I've described it, students usually, there's an immediate visceral reaction against this. And so it's an example of a utilitarian approach that doesn't take into account, that doesn't take into account human things in all their aspects, and that abstracts them, abstracts severe burnings into a dollar figure, which I think we all somehow think, and we have to think it through maybe why it's, but we all think that's somehow problematic.
Thank you, Sam. That's a terrific question. We've got another here from my colleague in the Herbst Program of Engineering, Ethics, and Society, Hardy Fredericksmeyer. Have at it, Hardy.
All right. Yeah, here I am. Okay. So I want, if I may, just tack on to your observation about ways in which scientism undermines our relationship with nature. I find the most beautiful descriptions of nature come from a pre-scientific era. And so, for example, Homer doesn't describe the sun, doesn't describe dawn as a gaseous ball rising on the horizon, but rather as, I just love it, as early born dawn spreading her rosy fingers over the Earth's surface. It's so much more beautiful. But if I may, this question involves something that's going on, right now. It seems to me that in a way that a humanistic view of the world is under pressure from a sort of double pincer movement. On the one side, scientism, and on the other side, pressure from humanists themselves, who argue, for example, that the great books on which you and I draw in our fields, I'm a classicist, that these great books should be discarded because they are products of an earlier, not yet woken, so to speak, time, not yet woken to racial and sexual inequality. And you might have seen that New York Times Magazine article this week in which a classicist at Princeton is arguing that the classics should be basically banned for that reason. I'm wondering if you have a key argument or response to that, again, that pressure being brought by some humanists.
Yeah, well, I think, so remember that people tend to be intractable. We tend to stick to our opinions, and let's say there's an irrational element in human nature which makes it very difficult for arguments to move us. But I think the arguments are, I presented the groundwork for those arguments in what I talked about. The arguments are there. I mean, it may be harder in a sense to make a case for beauty,
yeah.
but I think that case can be made, and it takes time to make it. I think that's one of the importance of freedom, and in particular, freedom of speech. And that's why the one voice out of the 100 may be the one right voice, and the other 99 might be the wrong ones. But I think, I don't know, it doesn't, the direction does not bode well, and I sympathize for whatever it's worth. But I mean, I guess you're in an engineering program as a classicist. What's I think maybe somewhat refreshing to me, if one can look at it that way, maybe refreshing is too strong a word, but for the people who dislike my classes and my program most are the MIT humanities people.
I'm not surprised somehow.
They hate them.
Oh, God. And why, may I ask?
The engineering faculty and students, because they understand ethics and thinking about engineering society is important.
Yeah.
Kind of know that.
Yeah.
They don't really know exactly how to do it.
Yeah.
And the students are interested. I mean, Professor Brooks and I were discussing a little bit earlier the number of students in your programs, which are amazing. I have over 100 students in my class in different sections per year, and they are take it as an elective, which is very tough.
Yeah, that's wonderful.
They want to learn these things.
Yeah.
So, I mean, we can talk about strategies to address this, but that would be, I guess, my high-level answer.
Well, thank you. If I could say one more thing, Shiloh the other day in a webinar, he said that his students, they seem to thirst for the kinds of things that you teach and that I teach and Shiloh teaches. And the thirst is there. I agree. And it's people who sometimes humanists, that is faculty, who are, it's not the students, it's the faculty, unfortunately, sometimes, or often. But at any rate, that was, I really enjoyed that. One last question. You said that it's harder sometimes to convince people of the notion of objective beauty. Were you saying harder than the notion of truth? Is that what you were, when you said that a few minutes ago or a minute ago?
I think it's harder because truth seems to be more directly associated with language. And so, as you said, you had to you gave a very nice, read a few lines or quoted a few lines of Homer in English, of poetry. So but then that has to somehow be translated into words in a different way,
Yeah.
or visual beauty, aesthetics.
Mm-hmm.
So I think it's harder. I think the case can be made. People have made the case, but I think it's harder.
Yeah.
One thing I did want to, before you go, I wanted to, you raised another point, which I think is interesting and worthwhile bringing up. So I've talked about science, of course, as this willful contrivance into mathematical abstraction. And you, in your few lines of Homer, talked about a different approach, a different picture that's poetic. I think there's something in between, which is more in consonance with nature. And it's actually very much related to the American regime, which is just going out and exploring nature as such. And you can see this, for example, in Jefferson Notes in the State of Virginia, where he goes out. It may not be as poetic as the Homer lines that you quoted, but he gives wonderful descriptions of just walking around his own property. And so if we just go out and look at nature, not as something romantic per se, but just trying to observe and see what we see and see how that, how we respond to that. That's something maybe in between this modern abstraction and the poetic description.
Yeah. Well, thank you.
Thanks.
Thank you, Hardy.
Yeah, my pleasure.
Spoken like a true Aristotelian, Professor Trout. We have time for one more. Blake Hogan, if you want to unmute, this will be the last one, and turn on your video. You don't have to turn on your video. Blake, from class.
Hi. Yes, awesome.
Hi.
First of all, I wanted to say thanks so much for doing this talk. It was very interesting, especially for me as an engineer and engineering leadership student.
Great, my pleasure.
And I was wondering, so in general, do you think that the concept of modern science can ever lead to true understanding? Or do you think that it is in itself at its base flawed in such a way that we're going to be continuously sanding a square peg to try and fit it into a round hole, but never actually reaching the right shape? Or do you think that there is a way in which we could eventually use the process of modern science in order to actually come across the essential truth?
Yeah, so you all asked very, very important and very profound questions, and time is always short. So I would, if we had a little more time, I would ask you what you mean by essential truth. But let me maybe just take a first pass at this, and you can follow up to the extent that we have a few more minutes. I was trying to make the case that by its construction, by its original construction and reinforced by its usage over time, it is an imposition on nature. And for that reason, actually, something actual about nature can't come out. But having said that, there are certain patterns that are observed. In answer to another question a little bit earlier about the wave function, and I was describing how it works. Modern science does capture certain patterns in a particular way. And I think understanding how it does that does allow you some understanding of those patterns. The problem is that I think is to realize that this very limited understanding, because of our mind's tendency to grasp something and then think of that as true and be content with that, allows us to stick with, at best, a very partial understanding. And so I would say in terms of reaching your objective of truth about nature, I think you would have to go far beyond modern science to do that. I think it's limited by its construction.
Okay, thanks so much. And also, I just had one kind of follow-up question. And so it seemed like kind of almost an overarching theme of what you were talking about is sort of a moderation between scientific education and thought, and then civic education, philosophical education and thought. And I was just wondering, I mean, in Dr. Brooks's class, we were talking a lot about moderation and kind of finding a balance between different philosophies and schools of thought. Do you think that it's possible that the philosophy of moderation in itself could be immoderate, in that if everyone is pursuing a moderate approach, that could be misleading in a certain way? And do you think that it could be important to have some certain people devoted specifically to a scientific method of thought, or like a pure scientific method of thought, and then some who are also devoted to a pure civic and philosophical sort of thought? Or do you think that the moderation needs to be each person rather than sort of a net moderation?
Wow, excellent. Fantastic question. That could be a whole nother talk for another day. But in just, this is great to think about, and I hope you'll be able to continue to explore this. So I think that the moderation comes in to society as a whole. And I mean, I'm certainly not advocating that we move back to a time in which we, believe in spirits and witches controlling, controlling the world around us. Clearly not. So I guess what I am simply advocating moderation, shifting back to science being understood for what it can do. One certainly has to be inspired by science, and I am certainly aware that if I'm pulling the curtain up over the contrivance, that tends to make it less interesting in a sense. But I think that one needs to balance this more towards moderation. You probably do need extreme people who have no moderation whatsoever and devote every possible moment of their waking days towards certain aspects of science. That's how you get these vaccines that are really helping us and will help the world. That's how you get things like this wave function that helped lead to the science that has allowed us to develop these vaccines. So, but I think in students like yourself, you need to understand that. And so I would encourage this moderation in yourselves. And I think that follows through to understanding science within the realm of civic education, or more broadly, liberal education.
Well, thank you. Thank you, Professor Trout, and thank you, Blake, for that great question. And everybody join me in virtually thanking Professor Trout. And don't forget in March to register for Erin Dolgoy. She will be next. Thank you all so much. Have a great day.
Thanks, everyone. Thank you, Professor.